Hello everyone, welcome to Homework Help. You can support the channel by becoming a member using the join button. In this video, we'll use concepts of implicit differentiation to solve the problem. As per the problem, two circles of radius 3 times square root 2 are tangent to the graph of y square equals 4x at the point 1, 2. Determine the equations of the two circles. As per the problem, the two circles are tangent to the graph of y square equals 4x. Y square equals 4x represents a parabola that opens to the right side. The vertex of this parabola is at origin or 0, 0. We can sketch this parabola like this. As per the problem, the circles are tangent to this graph at the point 1, 2. Let's assume point 1, 2 is somewhere here on the graph. So there are two circles that are tangent to this curve at this point. We can show the circles like this. We are given the radius of the circles. We are not given the center of the circles. The general equation of a circle in standard form is x minus h square plus y minus k square equals r square. H comma k represents the center of the circle and r is the radius of the circle. We are given that the radius is 3 square root 2. We can sub in this value of r in the general equation. Square of 3 square root 2 is equal to 18 because 3 square is equal to 9. Square of square root 2 is 2 and 9 times 2 is equal to 18. We have to find the values of h and k to find the equation of the two circles. For that, we have to use the concepts of tangent. As per the problem, the circles are tangent to the graph of y square equals 4x. So a tangent line that we draw at the point 1, 2 is tangent to the circles and the curve y square equals 4x. The tangent will be common to the circles and the curve. So the value of dy over dx for the equation of the circle and the equation of the curve at the point 1, 2 should be the same because dy over dx represents the slope of the tangent and the tangent is common to both the circle and the curve because the tangent touches the circle and the curve at point 1, 2. This is a very important concept we need to understand and memorize to solve this type of problem. So let's start by finding dy over dx for the equation of the circle. We have x minus h square plus y minus k square equals 18. We have to find dy over dx. So we should find the derivative of this equation with respect to x. Let's start with the first term, x minus h square. We should use chain rule. This term has the inner function x minus h and the outer function is the exponent 2. As per chain rule, we start with the derivative of the outer function. We have to use power rule. We move the exponent 2 to the front of the term and subtract 1 from 2 in the exponent times the derivative of the inner function x minus h. The derivative of x with respect to x is 1. H is a constant, so its derivative is equal to 0. This is the derivative of the first term. Now we can use chain rule for the second term, y minus k square. We move the exponent 2 to the front of the term and subtract 1 from 2 in the exponent times the derivative of the inner function. The derivative of y with respect to x is dy over dx. and derivative of k is equal to 0 because k is a constant. On the right side, 18 is a constant, so its derivative is equal to 0. This is the derivative of the circle equation. Now we can simplify this step. The exponent on x minus h is 1. We can ignore the 1 in the exponent. We have to isolate dy over dx in this equation. In the first term, 2 times 1 is 2. We can move the term 2 times x minus h to the right side of the equation. We get negative 2 x minus h. Next, we can divide both sides by 2 times y minus k. We can cancel out the 2's on the right side. I get dy over dx equals negative x minus h over y minus k. We have to find the slope of the tangent at 1, 2 because the circles are tangent to the curve at this point. So at this point, the slope of the tangent should be the same for both the circle and the curve. We should sub in x as 1 and y as 2 in this equation for dy over dx. This is the expression for dy over dx from the equation of the circle. Now we can analyze the equation of the curve y square equals 4x. We have to find dy over dx for this equation. So we should find the derivative of both terms with respect to x. On the left side, we have to find the derivative of y square with respect to x. We should use chain rule. The inner function is y. The outer function is the exponent 2. As per chain rule, we start with the derivative of the outer function. We should use power rule. We move the exponent 2 to the front of the term and subtract 1 from 2 in the exponent times the derivative of the inner function y. The derivative of y with respect to x is dy over dx. On the right side, the derivative of 4x with respect to x is 4. This is the derivative of the equation. Now we can simplify this step. The exponent of y is 1. We can ignore the 1 in the exponent. We can divide both sides by 2y. We can reduce 4 and 2. I get 2 over y. We have to find dy over dx for the tangent at the point 1, 2. So we can sub in y as 2. I get 1. This is the slope of the tangent we get from the equation of the curve. Since the circles are tangent to the curve at the point 1, 2, the slope of the tangent from the equation of the circle and the equation of the curve at point 1, 2 should be the same. Therefore, we can equate the values we got for dy over dx from the two equations. I get this is dy over dx from the equation of the circle, and this is the value we got from the equation of the curve. We can isolate 1 minus h in this equation. We should cross multiply 2 minus k to the right side. 1 times 2 minus k is just 2 minus k. Next, we can divide both sides by negative 1. This is the equation we get for h and k. Next, we should use the equation of the circle. This equation we got by subbing in r as 3 square root 2. Point 1 comma 2 lies on this circle because this circle is tangent to the curve at the point 1 comma 2. So we can sub in x as 1 and y as 2 in this equation. Next, we can do substitution for 1 minus h in this equation from the equation we got for 1 minus h. 1 minus h is equal to negative parentheses 2 minus k. So we can do the substitution for 1 minus h. Square of negative is positive. Two minus k square plus 2 minus k square is equal to 2 times 2 minus k square. We have to solve for k. We should divide both sides by 2. 2 minus k square equals 9. Next, we can apply square root to both sides. We get plus minus k, so 2 minus k equals plus minus 3. Now we should analyze the positive and the negative case separately. Let's start with the positive case. We can isolate k by subtracting 2 from both sides. 3 minus 2 is 1. Next, we can divide both sides by negative 1. I get k equals negative 1. Now we can analyze the negative case. We should subtract 2 from both sides. Next, we can divide both sides by negative 1. I get k equals 5. Now we can use these values of k to find the corresponding values of h. We should use this equation here. Two minus negative 1 is equal to 3. Next, we can subtract 1 from both sides. Next, we can divide both sides by negative 1. I get h equals 4. So the center of one circle is 4, negative 1. Now we can find the value of h for the other value of k. We should sub in k as 5 to find the value of h. Minus negative 3 is equal to positive 3. I get 1 minus h equals positive 3. Next, we should subtract 1 from both sides. I get negative h equals 2. Next, we should divide both sides by negative 1. I get h equals negative 2. So the second center is -2, 5. The first center we found is 4, -1. Now we can use these centers to write the equation of the circles. The first equation is x minus 4 square plus y plus 1 square is equal to 18. And the second equation is x plus 2 square plus y minus 5 square equals 18. So this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.